Some of you have viewed the video on Vimeo of my 7-band portable dipole antenna and have asked me to produce a video that covers the construction of my 7-band semi-vertical trap antenna, which was built approximately 6 years ago. So this is the video that you have requested. I recommend that you go into Google, type in my call sign, VE3HKY, Victor Echo 3, Hotel Kilo Yankee, and then look for the article entitled Trap Antenna. If you print this off and read the article, it will be of great help to you if you intend to build this antenna. As with all construction projects, safety is of prime importance. So I urge you to wear the appropriate safety equipment and take the necessary safety precautions when you are building or installing this antenna. This will provide a bit of an overview of the antenna, and we'll just go to the top of it, and hopefully you'll be able to see the top of it in the video. And that brings you basically to the top of the antenna. And I think you can also see the trap on the left-hand side. I cannot overemphasize that all fasteners must be stainless steel. You will be able to operate on 10, 12, 15, 17, 20, 40, and 80 meters without the use of an antenna tuner, and will have a very low SWR across the bands. This particular design consists of 3 sections. All are made of 6061 aircraft aluminum. The bottom section is 11 foot in length and is 1.5 inches in diameter. The intermediate section appears to be 10 foot in length and is made of 1.25 inch aluminum. And the top section appears to be 5 foot in length and is 1 inch in diameter. Now for the intermediate and the top section, where I say they appear to be, the intermediate section, which appears to be 10 feet in length, is really 10 foot 10 inches. And the last 10 inches of it is telescoped into the base section below to add stability. And likewise, the top section, which is a 1 inch, telescopes down into the intermediate section. So the top section appears to be 5 foot, it's really 5 foot 10. So in both cases, the intermediate and top sections are 10 inches longer than they appear to be, and that's just to add stability to the antenna. Okay, this is the base of the antenna, and we'll just point out a few things. First off, it's sitting on a corked wine bottle. We found that you get best results if you're at least 12 inches off the ground with the antenna. So that's the base, that's the very bottom of the antenna, the aluminum 1.5 inch tubing right there. Now this is the plastic that's been used to provide some protection, and that's a 10 foot length, and that protects the little people that are up on the deck. Here is a balun, and it consists of 23 turns of RG58U on a 3-inch coil form. So my wire is continuous. It comes from my shack, wraps around the balun, and then goes to the antenna. So you have the core of the antenna here, that's the core wire there, going again to the base. And over here you have the shield, and the shield of course goes to ground. At this point we have a ground rod, and it's 10 foot in length, so there's about 9 feet of it in the ground. And I'm going to give you a close-up, and I'm going to show you how we've attached the ground wires in just a moment. This here is a high voltage capacitor, homemade, and most people haven't bothered using them. It makes a bit of an improvement. It's a 25 picofarad. Later on I'll explain how I chose 25 picofarad, and it was through testing. So here we have our first of 5 standoffs, and this would be the wire going up for 12 meters. This is 17 meters, and this over here is for 20 meters. And the black wire you're seeing here is just a spare cable. It's not part of the antenna. Now it's very important to remember that the clamp that you use here, the ground clamp that you use here, should be made of bronze. Do not use anything made of white metal. It's only going to give you a problem later on. So what I've done right at this point here, which is where the wire would normally attach to the clamp, instead I've put a piece of copper tubing, small diameter copper tubing, and then I've soldered the 12 radios, ground radios, to the copper tubing. It works very well. So I have 6 that are 5 feet long and 6 radios that are 50 feet long. My lot, for all intents and purposes, is L-shaped with respect to this antenna. So I basically put them wherever I could put them, and it seems to have worked out extremely well. I've had no problems with it. I have 2 radios going underneath the deck, and that also works out well. Improves my pattern slightly. So just to repeat, the wire going up the side for 12 meters is 9 foot 2.5 inches long, and 17 meters is 12 foot 7.5 inches long, and for 20 meters it's 15 foot 10.5 inches long. Now again, when you cut them, and prior to tuning them with your antenna analyzer, make sure they're longer than that. That's approximately what you're going to end up. Now in this view, you'll notice that I've covered the top of where my radios are. I've covered it with a mastic material, and also here, where at the base of my antenna, I've covered it with a mastic material. It can be purchased from, I think, your local hardware store. It's sometimes used for sealing windows. It never hardens. It doesn't get stiff in the wintertime. Put a little heat on it with a heat gun, and you're good to go. And so they're wrapped, and I leave them wrapped like that to protect my joints. Now, some have written me and said that rather than use the balun that you see here, they've used the clip-on ferrites. And so instead of the balun, what they have done is taken 4 ferrites and just snapped them on to their feed and wire as close as I could get to the antenna, and that it did an excellent job for them. They had no problem whatsoever. So that's another thought that you can consider. Now, not everyone is going to have a deck, a plastic deck they can fasten to. I've seen some great installations where people have used either a 4-inch by 4-inch or a 6-inch by 6-inch post and set it in the middle of their backyard, and then use that. In other words, put it into the ground, say 30 inches or so. In some cases they've cemented them in, and it does a great job. And then they just use the same type clamps that I use here and the PVC duct, and it's worked out extremely well for them. Now this will offer a good view of several parts of the antenna that we need to look at. I'm up on my deck now, and you'll see this plastic part in here, and that's the part that provides protection if little people are on the deck. This here is the top of the base section, and you'll notice it's slotted out. Now you notice right here there are some very little bit larger slots. That was just from some initial testing. The narrow slots work just fine. And again, you'll see the double stainless steel gear clamps or pump clamps, whatever you prefer to call them. And you'll see remnants here of black grease, conductive grease. I use conductive grease on all my connections. So these are just some of the things you want to think about when you're building the antenna. And keep in mind now, this is the intermediate section up here. But that intermediate section, 10 inches of it travels down inside here, inside the bottom or base section, and that's to add stability to the antenna structure. One important lesson that you learn is to spend a few extra dollars on your gear clamps or pump clamps, whatever you wish to call them. What we found is that the band itself is not stainless. Others, the band will be stainless, but the screw part or the bolt part that goes through is not stainless, and you'll see the rusting. That's something that you definitely want to avoid. Spend a few dollars, get real good gear clamps, and don't run into this problem. Now, this provides a view of how these wires are spring loaded. You can see there's a special washer, and I'll get into the details of that washer, but you see that's spring loaded. So when these expand and contract in winter and summer, this takes up the slack, and it's very, very, very helpful. Prevents any problems with the wires becoming entangled or sagging. So I recommend it, and like I said, I'll provide you with those details. Now this might provide an interesting view. Looking up at the antenna, you should be able to see the trap and the wires going to and from the trap, and also to give you a view of the guy wires. So the third guide wire, as it were, is the wire that actually goes to the trap and then continues on and goes over to my fence. And the wire, of course, beyond the trap is for 80 meters, 75, 80 meters. And depending on the design of your trap, you may find a wire in the range of 26 to 29 feet will be suitable beyond the trap for 80 meters. Now that will provide you with a view of the top of the antenna, which of course is 26 feet in height, and you can also see the trap. And between the trap and the top of the antenna is 6'6". So 6'6" plus the 26 foot in height gives you, for the main mast, gives you 32'6", which is the required length for 40 meters. The wire I'm using is number 14 solid enameled wire, and we'll just move around here. Now this wire that goes beyond the trap, and again it's going to be number 14. Depending on the design of the trap, you may find a length like 25'9" will be ideal. Perhaps it's going to be longer. Perhaps it's going to be 27 foot or 27'9". What you want to do when you're tuning the antenna, you want to make sure that you are using an antenna analyzer, and then you decide what part of the bands you want to work on. I've designed mine, or I've adjusted mine for the phone section. Now that wire, which again is, in my case, it's 25'9", it's going to travel along, it's going to go to an egg insulator, and then eventually the wire will go across and be attached to this fence, which is off in the distance, which is at the end of my lot line, and it works very, very well. I'm standing with my back to the fence that I showed previous, where the end of my antenna fastens to the fence, and in there you can see the trap, and you can see the egg insulator, and that's a view of the egg insulator. You can see on the left side is the number 14 wire, and on the right hand side is the 1/16 Dacron rope that I use, and I use that both here, as you see, and I also use it for the other two guy wires, and it works out very, very well. The antenna has withstood winds of 100 kilometers an hour without any problem. That's just a view of how I have the guy wire tied to the fence, just wrapped around, and basically that's it. We're ready to demonstrate how we cut the slots in the aluminum tubing, and for this demonstration I'm going to use a scrap piece of 1¼ inch. This would be your intermediate section, and I'll give you a close-up of it and give you some of the things that are important to know. Now there's several things you want to keep in mind when you're going to cut the slots in the tubing, and of course we're cutting slots in the bottom section, which is 1.5 inches, and the intermediate section, which is 1¼ inch. I have a scrap piece of 1¼ inch that I'm going to use as a demonstration. The wheel that I'm using here, friction wheel, is a little more than 1/8 of an inch in width, and that seems to work out quite well. Now I'm using 1¼ inch, a piece, just for the demonstration. So for that purpose, you want your distance from the edge to the center of that wheel to be 5/8. In other words, you want to cut your slot right in the center. So 5/8 and 5/8, of course, is 1¼ inch, and it's 1¼ inch tubing that we're using. I recommend that the slot we cut is approximately 2.5 inches in length. So from here to this piece of wood that I'm just using as a stop, from here to the edge will give us 2.5 inches. And so that's what we'll use for cutting the slot. Now this is going to be a bit noisy, and what I've done, I can show you, I have pre-marked the tubing that I'm going to cut. I just made up a little template, and I have marks here that I've marked with a permanent marker. So I'll slide it off now, and that will form my marks for going through and for cutting this. Now it's going to be, like I said, quite noisy. Now, and again, first time through, I'm just cutting the bottom. I am using this at the top as a guide, just to eyeball it, so I know exactly where I should be. So I'll go ahead now and put on my ear protection, and we'll cut it. So you can see it's done a very nice job of cutting the slots. They need to be cleaned up now with a file, or you can even take an Excel knife and cut through the aluminum and clean them up that way. Both inside and out, you want them good and clean, so that you won't have any problem later on when you're telescoping your, in this case, your top section in. And as I've mentioned, the blade, you keep the blade down low. You don't want it so high that it would go through both sides of the tubing at one time. You only want to cut a slot in one side. So again, keep that down perhaps in the range of, well, certainly in the range less than an inch in height. And I think there I probably got it about a half inch. This is nothing more than a table that I bought. I try to use any old tools that I've got. I don't invest in new tools to do any of this. And this is simply just a stand that accepts underneath a skill saw. So it's just a skill saw mounted upside down, and that's what I'm using for cutting the slots. This is a view of the 1.25" that we cut slots in. And I didn't specifically say it, but there are, of course, 4 slots. And I've cleaned this up now, so there wouldn't be any problem sliding the 1-inch diameter section into this. And we'll demonstrate that. We'll put some gear clamps on there just so you can see what it looks like. Now this will provide you with an example of what it'll look like after you've put your gear clamps on. So this is your 1.25", that's your intermediate section, and this would be your top section, that's the 1 inch. And you see I offset the gear clamps or water pump clamps on opposite sides. I feel it gives me a little bit more strength, stability, and seems to work out very well. So that's what it looks like. And of course, as I mentioned earlier, normally I would put conductive grease, black conductive grease, which is very messy to work with. I suggest you use rubber gloves if you're going to use it. And then that'll prevent any oxidation. And as we discussed earlier, this section here, in reality, if this was really set up outside, then this top section here, 10 inches of it would be down below inside the intermediate section. Now, a number of people have written to me explaining how difficult it is for them to find a guy ring that they can use to attach their guy ropes. You can make one in less than 2 minutes. This is a piece of number 12 copper wire, and I'll show you in a moment how it's formed. And you use a single gear clamp, and that is it. In other words, your 2 wires are gonna, or ropes are gonna come off each side here. And then, as I had said before, the third is the actual wire going off into the trap and beyond the trap over, in my case, to a fence. So that'll give you an idea of what a homemade guy ring looks like. Okay, this mock-up represents the top of the antenna. Many people have written and said, well, how do you attach your horizontal wire at the top of the antenna? And this would be the horizontal wire here going to the trap, and then from the trap it would go to the over to my fence through Dacron rope or string, as it were. I use, here's the fastener that I'm using, which is a 8/32 a stainless steel bolt, 3/4 of an inch long, and I use them throughout. I use the same at the base of the antenna. I use the same for making the traps. One size seems to fit all, does a good job. I have no problems with it whatsoever. So that would be soldered. In other words, the number 14 solid copper wire would be soldered. Now when I solder, I always use liquid flux, and I have it in a hypodermic needle. I'll demonstrate that later on. So you would clean all the enamel off the wire at this location, and then you would just simply solder it to the copper strapping. Does a great job. Down here we have the clamp for the guy, and in reality it would be about 30 inches from the top, about halfway, because that's a 5-foot section, or at least a 5-foot section of aluminum tubing showing. As we know, it's 5'10", and the other 10 inches goes into the intermediate section, which is directly below. So you have 5 feet showing, 5'10" in actual length. So that works out very well, and we'll move from here into showing you how to make the little piece for your guy ring. Very, very simple to do. I'm starting with a piece of number 12 copper wire, enameled wire. And the first thing you do, this is 6 inches long, it could be 5 inches long. First thing you do is simply just wrap it around the post that I've got here, which is 1/2 inch. So anything that you have that's 1/2 inch in diameter that you can use in this manner should work fine. So that's the first part of it. Now, the second part, you just simply unclamp it from the vise. And put it back in the vise, clamped. And you've used this just as a spacer, and then simply bend it over with your fingers. So there you are, it's bent over. Okay, now we'll show you the next stage. Okay, I find it easiest just to now put a clamp around the wire that I'm going to use here for my guy, and just clamp it, and then just grab a hold of your wires here and just bend them back. Bend them back, and then you can trim them off because you don't need that length. And if you want, you can even flatten them a little after you've got them cut the size. Take a little off that. That should be just fine. So that's it. You've now made your guy clamp. So I'll just squeeze those in slightly, and that way it's going to make a bit of a better fit around the gear clamp. There. You're finished. That's it. So there we have our clamp for our guy ropes. Very easy, just slips on and slips off. Just slides right over, tighten up your gear clamp, and you're finished. Very, very simple, very effective. Now what we're looking at now is the coil that will become our trap. And the coil form is 4.5 inches in length. There are 30.5 turns of number 20 wire, and these holes are drilled 5/8 of an inch from the ends. And you should have no problem getting your coil wound on there and have clearance for the hardware that's going to fasten at these two locations. Now I'm going to show you now an excerpt from the video I did for the 7-band portable dipole antenna. And in it, you'll see how I make the coil form. It describes in great detail. Keep in mind that the lengths that I'm using are perhaps longer than what you will need here, but it will show you exactly how I make the coil form and the windings and what have you. Very straightforward, very simple to do. I'll come back to this and I'll show you how I put the capacitor inside, how I make the high voltage capacitor, and how we tune it. I've taken a piece of 3/4 inch conduit, PVC conduit, approximately 30 inches long. And you'll notice when you buy the conduit, if you buy a 10-foot length, that one end is larger than the other. That's called the bell end. And that's designed so that when you are using it as conduit and you have to add another piece of conduit, you're able to add a piece on without using a coupling. So in essence, that becomes a coupling. Now we're going to cut this off, but we need to save it. And after we cut it off, we will have a look at how we use it. Okay, we've taken that off. And now we're going to take it just a little bit further here. We'll take the take the miter box out and open the jaws of our vise. And then we simply take the hacksaw and we cut through it. We cut a slit in it. Now, we're going to use this in a few minutes, and it's particularly useful, and you'll see now that with ease we can slide it right over. We can slide it right over the conduit without any problem whatsoever. It opens up slightly, which is fine. So now we'll go into the next phase, which is the making of the actual coil, and we'll just cut off this end piece. So when we start, we're starting with a nice square end. Now we can break those pieces out of there without too much difficulty. And there's nothing exact or perfect about how you cut this, as long as it serves your purpose. So there, we've now got a slot in there, and that will take us to the next part of the demonstration. Now this is a 1-inch pipe die for 1-inch national pipe thread, and if we take our conduit, our 3/4 inch PVC conduit, we'll find that it slips right through, no problem whatsoever. So what we do is we take our die and we modify it. We've removed the 4 screws that were holding it in place. We take the cap off of it. Now what we do now is we advance the 4 dies towards the center, so it creates a smaller circumference. Now be careful, because they are numbered 1, 2, 3, and 4. So counterclockwise they are numbered to give the proper cutting. Now what we want to do is, we have a couple of choices here. We can use, as it were, a number 14 wire and number 12 wire. A number 14 wire is about 65 thousandths thick. What I have been using, and it's somewhere in between a number 14 wire and a number 12 wire, are just plastic spacers that are about 74 thousandths of an inch thick. So what I will do is I will nest them in there. I will push the dies in that thickness, then put the cap back on. Now that'll provide a view of the spacers just taped in place with masking tape. And once we have the cap on, of course, they'll stay in position, no problem whatsoever. Now I'm certain that a lot of what I'm showing you today will not be found in the machinist handbook as good practice, but it does work, and it's worked very well for me without destroying anything. There is that piece that we slit, and that's going to fit onto there, and then it quite nicely fits into the actual die as a spacer to hold the conduit centered. While we're running it through with the electric drill. Now we had a slot that we cut in it. We have a slot that we cut in here. This 1-inch wood bit fits into there perfectly. So you fit the 1-inch wood bit into there. You can slide this back at any time. What it's doing, it's preventing the PVC conduit from splitting, from opening up. We don't want it to open up. So we're going to put our drill in there, and we're going to put the piece of conduit, as you see there, and then we're going to go ahead and we're going to start our drill. And we'll stop there, because we certainly have gone far enough. And now we are going to reverse the drill, and we will bring it out. Okay, I don't own a good reversible drill that has considerable power, but I do have a portable one, which is suitable for extracting and working backwards now that I've threaded the PVC conduit. So that'll give you some idea of just how easy it is to make the coil form. I oftentimes use 5 feet and run 5 feet through at a time. Our next step will be to cut this to the size we need, and then go from there. Now this will provide you with a view of the coil form, or the PVC conduit, which has been made into a coil form. It comes out in quite good condition. This is a piece of printed circuit board material. It's double-sided copper, and it's 1/32 of an inch thick. It measures widthwise 3/4 of an inch by 2.5 inches. And what I'm going to do is make this into my high voltage capacitor. Now before I do, I make sure that I sand all of the edges. All of the edges all the way around must be sanded to ensure that there's no little pieces of copper over the edges that are going to cause a problem later on. So I use emery cloth, just a very a light gauge emery cloth, and sand all the edges before I do any soldering. Now I use this tool, which comes in very, very handy, and I just use that to scrape the enamel off the ends of the wires that I'm going to solder. And then after I've scraped all I can off with the tool, then I just use some emery cloth. So we'll just demonstrate how we solder the wires. So now I'll just squirt a little bit of liquid flux at my point where I'm going to be soldering. And I've put a Kelly clamp that holds the wire down very, very nicely. It prevents you from having warm fingers. And then you can just go ahead and solder. And it will keep your wire nice and tight to the printed circuit board material. There you are, no problem. Now I do like things to be consistent in length, etc. And you'll see that I've used this board just to set the length of my wire coming off of my coil. And now I've done the same thing here. I've got this wire here that's on the capacitor. Those two wires are the same length, and we'll put that together. We'll tack solder it, and then we'll do some testing. Now keep in mind that this coil form is again a 3/4 inch conduit. It's got a 3/4 inch ID. In fact, it's a little larger than 3/4 inch. And I think I've described the coil to you in terms of how it's made up. We'll show you now how we test it. Okay, I got the length of the printed circuit board to 2 1/8 inches, and at that point is where I have my lowest SWR, and I'm running it at about 6.979, so about 6.98 is where I'm at right now. I was aiming for 7, so that'll be just fine. So that's 2 1/8 inches, 3/4 of an inch wide, and now I'll go and dip it in hot glue. We're outside and a long ways away from vehicles and the house and what have you, and on my barbecue I have just a bit of a spoon that I bought at the dollar store, and I'm going to be using that to heat hot glue. There's hot glue in there, and we'll heat that up. And then when it's all melted, we're going to dip our capacitor into it, and that will hermetically seal it. Now there's the capacitor there, and we'll put it in there once the hot glue is hot enough. I think the hot glue is hot enough now that we could put the capacitor in it. And if for any reason we leave it in too long and it becomes unsoldered, that's not a problem. So we'll just quickly dip it in and take it out. And that's basically it. We'll let that run off. If afterwards we have to trim it in any way, it's no problem using the heat gun just to flow over the edges again. Okay, I've used this heat gun just to melt the hot glue. In other words, what you do, you set your capacitor on end so that the hot glue can run down, and you just warm it with this. Don't overdo it. If you do, you will melt the solder. And if you do, you can resolder it very, very simple using your soldering pencil. No problem whatsoever. No need to put any more flux or anything. It'll solder perfectly. You won't have a problem. Now that'll provide you with a close-up view of what the capacitor looks like now that it has the hot glue on it, and it's completely sealed. And we've used, as I just showed you a moment ago, the heat gun to take the excess hot glue off of it. Now what I've done is prepared a bit of a pictorial or a schematic, whichever we prefer to call it, of the interface that I've made up, and I'll show you that in a little better detail, real close up in a minute or two. What we've got is this would be where your end connector is, and this is the center pin of your end connector would come to that point. This here, of course, is ground, and the shield or the outer casing then of your end connector connects to that point. So all we're doing is we have a 180 ohm resistor coming, again, would be off the center pin and going to ground. Now we have another resistor, 15 ohm, again coming from the center pin, as it were, and going through a .01 or a 102 capacitor, whichever you prefer, and coming down to this position here. This position here is where I have my alligator clips fastened, and from the alligator clips, of course, I make one loop around the actual trap, and that's how I do my measurements. Now this has worked very well. It's a circuit that I did see on the internet, and I've used it, and I've had no problems with it. Now, any of the results that I'm getting here today, I believe, because I've done this before, and then I've compared with 2 commercial units, and in both cases, this checked out as being very, very accurate in terms of the SWR being, in fact, the resonant frequency of my trap. So I'll just give you a close-up now of the printed circuit board that I made, and of course you can follow this diagram, I think, without any problem whatsoever. Now that should provide you with a good view of the underside of the printed circuit board and just how I have it fastened into the end connector. You should be able to see that on the side. I've just simply soldered it in. I've cut a slot in the BNC portion of the end connector, and then just mounted my components on it. Very simple, very straightforward, but seems to work very, very well. I've had no problems with it whatsoever. We're ready to assemble the capacitor, high voltage capacitor, inside the coil assembly to make up our trap. I just wanted to make sure that you had noticed previously, perhaps not, but we've just drilled a hole there to bring the wire up through, and same on this end. So that's how you get a half a turn. There's a half a turn there. And I'm sure everyone realized that when I was testing that I had these wires joined together at this end, as well as the wires at the opposite end joined together, so that I could test and determine the resonant frequency. Now what I've done is I've soldered these on. These are just eyelet connectors that are squeeze connector, but on top of that I've soldered them. So they're soldered inside, and it just makes for, you know, better results, more long-lasting results. And you want these, that is the back part of the eyelet connector, you want that to face up. So the back of the connector is facing up. Mechanically it just works out better. And I've got the same here. The back of the connector is facing up. And now I'll get into putting the bolts through. And what we're going to do is use, again, this is 832 by 3/4 inch long, and we can just guide it in to the eyelet connector, and that shouldn't pose a problem at all. And there we are, coming through, and now it's just simply a matter of putting a flat washer on it, and again, all stainless steel. Flat washer, lock washer, and nut. And then we'll just do the other side and tighten them up. and give you another shot of it. Well, we're pretty much finished with the trap. Just a couple of things I'd like to show you. One is your trap is going to hang this way. It's going to hang from these two bolts. It's going to be hanging down from these two bolts. Therefore, inside, I made sure that the printed circuit board is oriented so it's across. Okay, so if you could see right down inside, and perhaps there you can, you'll see that the printed circuit board is across this way, which means if there's any water laying in the bottom, your printed circuit board, your printed circuit board capacitor, I should say, will not be sitting in water. So that's just something to keep in mind. So here I've got a flat washer, lock washer, and a nut. And I've just simulated this. You would have, of course, wires coming out both sides of the trap. So after the flat washer, lock washer, nut, then you have another flat washer. You have the number 14 wire that you're going to use, horizontal wire, another flat washer, a lock washer, and then a nut. And all that fits very, very nicely, and it would hang downwards. In other words, this would be down. This would be the top, the sky, and this is down. And that's how it's going to be hanging. Just to demonstrate, what I've done is I've put heat shrink tubing on here. Some might like to do it. Certainly not required, but I put it on. Make sure if you're going to put it on, you put it on before you put your bolts on, or else you'll never get it over. So you have to slide it on. At least you have to leave one bolt off in order to get it on there. So that just gives you an idea of what it looks like if you did put heat shrink tubing on it. And that's pretty much it. Don't worry about the fact there's no end caps. You don't need end caps. Your wires are well soldered. You're not going to have a problem with them. Mine have been up 6 years, and I haven't had a moment's problem with it. And my SWR today is the same as when I put the antenna up 6 years ago. I've left the construction of the standoffs until the very end. I think many people would look at that and say, well, gee, I can't do that. There's a radius cut into the end of that. How would I ever do that? And there's a slot in it to take a gear clamp, and then the holes for the wires to go through that run up the side of the antenna. That would be impossible for me to make. What I'm going to show you here will make it very, very simple to make these, and to make these very, very accurately without any real difficulty whatsoever. This again is a piece of 3/4 inch PVC conduit, and we'll get into the actual building of it, but first I'm going to show you what it is that I use that makes this job very, very simple. What I have here is a slide, and this slide makes it very, very simple with respect to making up the standoffs. And I actually gave away my slide to a person who wanted to build some of these antennas, and so I've cut wood to make 2 more. And I'm giving you the dimensions of what to build. I show the thickness of the plywood and all the dimensions, and I'm going to show you a side view of it. And hopefully all the dimensions will be visible, and you'll be able to make your own. Now that's an end view, and now I'll show you a side view of the slide mechanism. I'll build mine, and then we'll get into using it. That is another view of the slide, and again, you'll have more dimensions shown there, and hopefully you'll be able to see them on your monitor. And you can see on the top, I have pieces of copper, again, copper strapping with some electrical tape, and they work as hold downs. So I'll go ahead and make up one, and then we'll use it for this project. Well, this will give you some idea of what we've built. There's the base section of it. And I've nailed the wood strips along the side using 1-inch finishing nails, and of course I use the bottom piece here as my guide. In other words, I just slipped that in there, and then I glued and nailed using 5 finishing nails on each side, 1-inch finishing nails, and that gives me my slide that I'm going to need. Now on top here, what I've done is I have, again, I've used a spacer, and that's the 3/4 inch PVC conduit, and I've nailed and glued. In this case, it's thicker, so I've used 1 1/4 finishing nails here because of the thickness of this wood and the underlaying plywood. So that will show you what the slide looks like before we use it. Keep in mind that once you've made this, the slide might stick, so just sand the edges on both sides. Sand them so that it narrows it slightly, and then you'll have no problem with it going back and forth. Now keep in mind that at this end we have an undercut, and you're going to see how that undercut serves us later on, and I believe that is dimensioned on the drawings. Okay, we've progressed a little further here now, and what we have is we have installed these straps, which will become useful. You can move them wherever you want. I have marked the center line of this 14-inch long piece of PVC conduit. Now you'll recall what we want to get out of here is two 6-inch long pieces, and we'll do that in a moment. Here I've marked the center line, and it goes right through. This will prove to be very useful in the next few steps. Now what I've done is I've put a screw in here, and I'll show it to you, to act as a stop, because when I've been making these, I've been making many of them, perhaps 30 at a time. And so it was very easy for me just to lock everything in position and then to simply slide down, knowing that my conduit would be right in the center. And again, you can put a clamp on this, you can do whatever you want in order to hold it in that position, or just reference it, eyeball it, and that will work out very, very well. I think I've said before that the nails that I used here are 1.25 inches, and the ones that I used here are 1 inch, and that seems to work out quite well. So we'll move into the next phase, and in the next phase you'll see how we cut the circumference that we require, and move on from that point. Now we have everything set up to go ahead and to drill our hole here and create the circumference that we need. Just keep in mind that this board here, the slide, can still move. And so if you were going to be doing many of these, and in my case you're going to be doing at least 3 of these, you need 5 for your antenna, then simply put a clamp. So I've taken a clamp here, and just put a clamp here between the bottom of this and the slide, and now you're locked in. So you can just keep sliding new pieces in. At the end you have your screw that's acting as a stop. So all you do is put another piece 14 inches long, put it to there. You're okay, you're good to go. So I have centered this up this way, so I know I'm right in the center. And we're going to go ahead and we're going to drill that out. And that should cut the circumference for us. Now what we have done there, of course, we've cut our wood for the first time, and then we'll use that again in the future. And we can pull that out now, and we have the circumference that is required. And this is just nothing more than, most everything you see here is a dollar store special. This is for cutting holes that you might be using if you're installing a lock set in a door. These are dollar store clamps. And the drill that I'm using, the drill stand here, is a $50 one that I purchased here new here in Canada. So that will give you an overview of how we cut that, and it does a great job. So now we've cut out the 2 pieces. That'll give you a view of them. They need to be cleaned up a bit. There's some burrs around the edges, but you can clean them up. I use just this, sort of a scalpel, and it does a good job. I use it. This is what I used also when I cut the slots in the aluminum and used it to clean up. It does a great job. So we're going to move on from here, and we're going to put our holes that we require for the wires to go through. Now in this next part of the video, I want you to pay particular attention to here. You see there, you can see the circumference. That's the part that's going to go around the pole. Now this here, you can see, this part here would be the bottom, and the top would look like that. So it's very important that when you go to drill the holes for your wires, that you have this oriented correctly. In other words, you can see the dip in here. Okay, that's what you need, because keep in mind, think about how that's going to sit around on a post, on a 2-inch mast, and then you'll realize the orientation. Okay, so that's indented. So it's the indented part here that's important in terms of drilling the holes. Okay, on the PVC conduit that we're using for our standoff, I have marked the position where I want my holes. Now this is the first one, and that's 3/4 of an inch in from the outside edge. Okay, the next one here is 2.5. So from here to here is 2.5, and finally this last one here, which will just miss my strap, from here to here is 4¼ inches. So we're going to go ahead and we're going to drill them now. We're using a 5/32 drill bit, which works perfectly with the number 16 wire. And again, it's number 16, and it's insulated, stranded wire. Now, what's important to note is, in order to make it easier, I have marked this. I've marked this center line, and I've marked a dot out here. So when I go to drill my second one, and even this first one, all I have to do is line up with those marks, and I'm in the exact right spot. There's my next one, and there's my final one. Now I'm utilizing the stop, the screw that I put in here, and now I can you'll be doing 5 for your antenna, or I guess in essence cutting out 6, but you know exactly where you want to be. In other words, you want that dot lined up with the center line of this. So there again is your 3 spots. There's your second, and there's your third. So we'll go ahead and drill them, and you'll get a better look at what we've got after we've drilled those out. Again, that you're going all the way through. Your wire has to go all the way through. Now we should have the holes that we needed. Now you might find that it's much easier for you to take the slide right out. See, I've removed the slide. I've got the slide in my hand, and you can eyeball it very nicely in terms of finding out, you know, have you got it in the right position. And this will give you another view of it. There's the high point. That's not what you want. Okay, there's the low point. That's where you want to be. That's where you want to be when you're drilling out. So what I've done is I've taken the other one that I cut, and I'll just show you how easy it is to simply put it in and drill out the 3 holes without marking anything, because we already know where it is we have to be. There's our first hole right there. So we know where that's at. We'll just move this up a little bit, give you a little better view. We can still see our marks, and we'll go ahead and we'll drill those out. Okay, we've drilled them all out. Okay, what I've done is I've clamped the slide. The slide is clamped to the base, so the slide can no longer move. It's locked in place. And then we're going to go to the next step and show you what we've done, and then we're going to go ahead and cut the slots in just a moment. Okay, just a couple of things to illustrate here. One, what I've done is I've put in this stop. So this is a piece of 3/4 inch PVC conduit, just cut flush. I've screwed it in, so it's screwed into the slide. Now I've already shown you that the slide is locked in place, so it cannot move. Now what we have is we have a stop, so that now we can cut our slots into the end of the PVC conduit. And I'll just show you the other end of this to show you what I'm using to make sure that when I do it, I get an accurate slot. Okay? So, and keep in mind that this time when we're cutting slots, it's the proud or the piece of the PVC conduit here that is forward, not the back part. It's the forward part. And there's our stop, and we're set up. We can cut as many of these now as we want. What I have in here is a 1/8 inch short drill. The reason I've put in a short drill bit is that I don't want any flexing. I want to minimize the flexing of the drill bit when I cut the slot. And so that's what I'm doing with this, using a short 1/8 drill bit, and it should give me good results. Okay, what I've done is I've got this piece of metal, round metal, that just fits nicely into the slot. Okay, or into the hole, I should say, that your wires will eventually go through. It's 2.5 inches long, and I have put a piece of heat shrink tubing on this end just to act as a stop. In other words, I want to know where that's at all times. Okay, I don't want it to go all the way through. So I've just got that lined up there, and we're going to toggle back and forth as we bring the drill press head down, and then we will cut our slots. So I'll move that over so you can get a better view of the drill bit. Okay, we're ready now to make our slots, and I'll bring the head down, and now I'll just toggle over. Back, make sure it's clean. That's one side done. Okay, I've put the one slot, which you can see there. I've just simply turned it over, up against my stop. I'll start the drill press again. Bring it down. I just thought I'd let you see this. When I cut my first hole, I wasn't paying attention to keeping this pushed forward. You have to have it pushed forward against the stop. So that'll show you what will happen. If you don't push forward, the bit will or the part will move on you, and it won't give you a perfect cut. So keep that in mind. Be pushing forward on this stop piece so that you get a perfect cut. The other side, of course, is a perfect cut. There's no problem with it whatsoever. That'll illustrate to you that the clamp goes through just lovely. It's no problem whatsoever. You put that around your mast and tighten it up, and it pulls it right in, right against the circumference of the of your mast. Should be no problem. Now, from here, I'm going to give you some other details that may help you. We're approaching the end of the video, and at the very end I will show you SWR results for the antenna, and they're just as true today as when I first built my antenna. First, I'm going to go through a few things that maybe provide additional details or clarify certain items that may be helpful to those that decide to build the antenna. There's the bronze ground clamp that I referred to, and again, I recommend you use a good quality clamp. Spend an extra $1 or $2, but get a very good quality ground clamp. The ferrites, and I mentioned that some people are using Snap-on ferrites. There's an example of one right there. What people are telling me is that they're putting 4 of these in series on their lead-in right next to the antenna, and that it does a great job for them. So that's something that you can consider. This is the spring, and this is the washer that, of course, go at the top of the wires that are on the sides of the antenna. That's a 1 inch by 3/8 compression spring. I bought these at FACA Fasteners here in London, and there's a very similar one that is sold by TSC, Tractor Supply Company, and it's actually a replacement part for milking machines, so that may be a hint. This decorative washer, which again is stainless, is also sold by TSC. Make sure that the diameter of the hole is proper for the wire that you're using up the side of the antenna. That is very, very important. Now I'll just show you the again the guy wire arrangement, and what I've done is I've just put on one wire. So you would have one guy wire going over in that direction, and then you would have, of course, one coming in this direction for guying it. So that just gives you a view of it, what it looks like when you actually have it in place on the antenna. Now, metal supermarkets, and they have outlets throughout North America, both US and Canada, sell the aluminum tubing, and they will cut it to size for you. And you know that the total length is going to be 26 feet plus the additional footage required for inserting it into or telescoping into sections below. So the last time I purchased this, which was in 2010, the total cost including tax was $43. And I'll just mention that the first section, which is 11 feet, I chose 11 feet so that I would have sufficient room to slide over a 10-foot length of the vacuum cleaner duct, and then still have room for my clamps to clamp the section above, and of course to terminate on the base of the antenna. So those are the reasons behind what I've done. Some are going to ask, well, can I use just two sections? Yes, you can use two sections or one section or whatever you want to do, as long as the total length of it comes to 26 feet. That's what's really important, that it's 26 feet in length. And again, any combination, I recommend staying with the aluminum. Some people have wanted to use galvanized or some other kind of pipe. Keep this in mind. I'm 69 years old. This movie is being shot in December of 2011, and I have no problem raising this antenna or taking it down by myself. It's very, very light. I don't think the total antenna weighs more than 5 pounds, and it's very, very easy to handle. I have no difficulty with it whatsoever in terms of taking it off or taking it down or putting it back up by myself. So those are some things to keep in mind. When I presented this adapter, I made reference to N connector, and the N is the letter N. It's an N connector as opposed to a PL type connector, and you see it goes from N to BNC on the rear, and that's what I use to build my my adapter. Now I require an N connector for my antenna analyzer, and that's the reason why I have gone this way. You'll have noticed that this end of the slide is undercut, and I do give the dimensions for it. Some of you may be wondering, why did I undercut it? And here's the reason. It's to increase the amount of arc, and that additional arc is required in order to cut the appropriate slot. And so that's the only reason for doing that, is just that if I didn't have it, I wouldn't be able to travel as far. My travel would be limited. So it gives me the arc that I need in order to cut the slot appropriately. Now the circular saw that I've used is a 2-inch, and the thing to keep in mind is that you need a 1-inch, at least a 1-inch depth here. Okay, from the teeth here to the base, you need at least 1 inch, and the reason is that you're traveling through conduit that is 1 inch in diameter, and it does a great job. And again, it's just a cheap hole saw cutter, 2-inch. I've heard from a couple of people that read the article on the internet with regards to this antenna and believe that this was part of the final installation. This is not. This is for testing only. What I recommend is that you add approximately 29 feet of wire beyond the trap that will cover 75-80 meters, and then tune it. Use your antenna analyzer and tune it to where you want to be on the band. As far as 40 meters go, you have a 26-foot mast, and you have 6'6" of horizontal wire for 32'6", which is what's required for 40. I think you'll find that you're going to be right on, or very close to being right on. You might be able to telescope the antenna in or out, perhaps half an inch, and make some difference. But I have found on all the ones, and I've been involved now in building about 10 of these, that there was never any problem with the 40 meters. 10 and 15 meters, you're going to get what you're going to get. And again, I have found it to be ideal. There's no adjustment for it. So what that leaves you with is the wires going up the side for 12, 17, and 20 meters. I'd recommend that you tune 20 meters first, and then 17, and then 12. And I think that your results will be very encouraging. Now, the purpose of this, after you have it tuned the best that you can possibly tune it, let's say mechanically, then what I have done is I have taken this motor arrangement. This is a furnace humidifier motor. This is a 140 picofarad capacitor which can run continuously. I have clipped that on, one lead to the base of the antenna and one lead to ground. And using my antenna analyzer, I've gone to the center of the bands and where I want to operate, which is the phone section, and then I've allowed this unit to run. Now, the power for the motor comes from my shack. So I'm in my shack, this is plugged in outside, and I tune it to the center of each band, one band at a time, and then I let this run. And when I see the lowest SWR, I unplug it. I go outside, I measure my capacitance. I go to the next band. I repeat the process. Tune to the center of the band, let this operate until I have the lowest SWR, and then go outside, measure the capacitance. This will have really no effect on 75, 80 meters and 40 meters. It will on the other 5 bands. It will offer an improvement. I found that the capacitance, when I measured it, it ranged from 15 picofarad to 35 picofarad. And so I compromised and made up a high voltage capacitor that measures 25 picofarad. So I'm more or less in the center. And the method for making that high voltage capacitor is the same as I've already explained in regards to the trap. I make it the same way. I cut it, I trim it, I measure the capacitance, I dip it in hot glue, I then set it outside, and it stays there. And it's protected, it's basically hermetically sealed and protected from the elements. I wish you the best of luck if you decide to build this antenna, and certainly you're more than welcome to email me if you have any questions with regards to its construction.